For my Geography 34, 35, and 2020 classes, I provided a flash drive that has a number of resources provided for you on those. Today we're going to talk about one of the quiz reviews, in particular quiz number 1. You can see what the flash drive kind of looks like. I've got ArcGIS, documents, final exam. If you're taking it in a future semester, it might look a little bit differently. But if we click on the quizzes folder, we'll see quiz 1 old, quiz 2 old, quiz 3 old, quiz 4 old. These are just some of the quizzes that I've given in the past. If I were to click on quiz 1 old, I'm just going to talk about the answers today and how I went about getting those. These are the questions here. The quiz that you will be taking will have different questions, but I'll talk about these so you can use these as a resource, and obviously you can bring these in to the quiz 1 when you're taking it during my class. Number 1, the largest component of any GIS is people and data. Okay? The people and data that go into making GIS data, developing GIS data, are the most expensive component. Our hardware and software are relatively inexpensive. The software that we work with is maybe $2,000. The hardware that we work with could be about a $1,000 laptop, but we're typically paying GIS professionals, $1,000 a week to develop data and pay for their services. Number 2, relative to the fundamental themes of geography promoted or proposed by the AAG, latitude and longitude refers to location, in particular absolute location as opposed to relative location. Number 3, the power of GIS is that it's able to link points, lines, and polygons with real-world location with a table that contain information or attributes about each spatial catalog. So when we talk about the examples in class, we might click on a sex offender on that particular map. We click on that map that has real-world latitude and longitude, or northing and easting, and information about that particular person will come up. We might be looking at environmental remediation sites, sports franchises. In the class that we're taking, 34, 35, I've given examples on parcels. So you can click on a parcel and see who owns it. And that's contained in a table. Number 4, we typically use GIS to make maps or decisions about a problem that involves a spatial component. Where are we going to build the next Walmart? Where are we going to build the next the beltway that goes around a city? Where are we going to site a potential location for a television station or road or whatever? So we typically use GIS to make decisions. Where are we going to allocate resources? Number 5, I haven't given this recently, but the snow map of 1854, this mapped cholera. And the snow map of 1854 was a map that we looked at in London that mapped all of the cholera cases. In more recent classes, I haven't used this example here, but I'm just putting it here for your reference. Number 6, the collection of data from a distance is what we call remote sensing. We have examples like LiDAR and radio telemetry. Those are examples or subsets of remote sensing, but this is taking images from a drone or an airplane or a satellite. Or if we put a monitoring station somewhere and we send it up to a particular location that we can collect. So this is called remote sensing. The blank data model represents real-world phenomena as geometric objects such as points, lines, and polygons. That's the vector model. Number 8, which of the following phenomena would not be best represented using the raster? That would be roads. Elevation, air temperature, and snowfall are what we refer to as continuous phenomena, meaning that they occur everywhere. So any place on a particular, state or, grid or whatever is going to have air temperature. It'll have snowfall. It'll have an elevation that we can map using tiny little pixels. These tiny little pixels are what we look at on our digital camera. Number 8, as we increase the resolution, which of the following is true? Both the file size and the processing time increases. So when we buy a brand new digital camera or a brand new phone that has a better camera, we increase the resolution. That means there's more pixels. If there's more pixels, that means the file size is bigger. So when we go from 1,000 pixels by 1,000 pixels to 2,000 pixels by 2,000 pixels, basically we've multiplied the size by a factor of 4. And as in such, the processing time is going to increase. So if we want to text that, or we need to process it, or we need to get rid of red eye, or whatever it is, whether it's GIS related or non-GIS related. Number 10, a state would best be represented as a polygon, right? Because it has area and it has perimeter. We can measure stuff inside of it. Number 11, the vector GIS data layer. In a vector GIS data layer, each feature is linked to a single, what we call, record that contains information about it in an attribute table. So I can click on a sex offender and it'll just have one record. I can click on a parcel, I can click on a volcano, I can click on a county, and it's just going to return that one single record and all of the attributes attached to that record. On a 1 to 100,000 scale map, 1 inch is equal to about 1.5 miles on that paper map. Okay, 1.58 miles. So we divide that magic number, that scale, by 63,360. That's the number of inches in a mile. Number 10, the type of projection that measures units in degrees latitude and longitude. That's what we call the geographic coordinate system. I haven't used this question on quizzes recently, but you might see this again. Number 4, the word quality, okay, refers to the number of errors contained in a map or data set. Okay, and in particular, this term is accuracy. Okay, accuracy. So we talk about data quality, and data quality refers to accuracy. How accurate are you? Basically, when you take a quiz, you're measuring how accurate you are compared to what I think a correct answer is. Number 15, if we're working with data that's out of date or has not been updated in a number of years, this is what we call temporal accuracy. Okay, temporal accuracy. Number 16, I have a field called average family size. The number of decimal points is what we refer to as precision. I can measure the width of a room using a ruler or a yardstick, but I can get much better measurements if I use a more precise tool, such as a rangefinder or something like that. Last question we have here, last 3 questions are hands-on. So if I were to go to the quiz 1, there's an MXD file that has the little world button. If I were to click on this world file, this MXD file, you will see a MXD that pops up, and we answer the last 3 questions about that. The quiz that I might give you might have 3 questions, it might have 5, so these are just examples that we're doing for this particular review. What is the least populated county in the state of North Carolina? Now if I right mouse click, open the attribute table, I go to POP 2010 or POP 2013, I can just right mouse click and do sort ascending. So right mouse click, sort ascending, and basically the one at the very top or the one at the very bottom, if we do descending, is Tyrrell County. So you can see Tyrrell County is the least populated. All the way at the bottom is the most populated. How many records are there? Records, there are 100 records here. So there's 100 counties in North Carolina, 100 records. The attributes would be the number of columns. The records which read down are 100. You have to actually go through and count these. There's other ways that we can count these. But there's 100 records here because there's 100 counties. The last one says, look at the attribute named average family size. What is the average of all this average? Okay, the average of the average. So I have something called average family size. Where is it? Okay, average family size. If I right mouse click, I look at statistics and I can see a nice histogram right here that shows me the distribution of data from the scale between a minimum of 2.7 to 3.3. So family size is just the number of people in a particular county, because this is at the county level, divided by the number of families. We've talked about the difference a little bit between families and households. So the number of people per family. So in some counties, there's only 2.7 people per house per family, up to 3.3. And then the average of all of these is going to be 2.9499. We can round this to 2.95.